Okay, good morning class. So this will be the solutions for the Lex Practice section in your mathematics textbook of chapter 6, page 145. Okay, so first question. Mina has a packet of sweets. She gives half of her sweets to her brother. After eating 3 sweets, there are 5 sweets left in the packet. So how many sweets were there in the packet initially? Okay, so in any algebraic problem solving, we will first define what our variable means. So, how many, okay, what we wanted to know is how many sweets were there in the packet initially. So, let the number of sweets initially in the packet be P, and then as we know, she gives halves of a sweet to her brother first, and then she eats 3, and then there is 5 left. So there we can form an equation. P, she gives half, okay, so times 1 over 2, minus 3 which she has eaten, and then we have 5 left. Okay, so we will plus 3 on both sides to get this, and then you divide by half on both sides, and then you'll find out that P will be 16. Alright, next question. In a cross-country run organized by a school, the students who have completed the run within 1 hour would obtain 2 points for their teams. A total of 28 students managed to obtain the points. The number of boys who obtained the points was 60 more than the number of girls. How many points did the girls obtain during the cross-country run? Okay, now there's a lot of information here, so let's take a look. Is this a linear equation with one variable, or is it simultaneous equations? Okay, so it seems that I can't form any equation out of this. Obtain 2 points, and then there are total of 280 points. 2 times even if it's 2 times y, then I don't think I can find any I don't think I can find any equation that would relate later. So let's see. The number of boys who obtained the points was 60 more than the number of girls. Okay, but here, and I have 280 students. So let's see. I think we can form an equation here. Okay, so let the number of girls who obtain the points be G. Okay, and then the number of boys who obtained the points was 60 more than the number of girls, so it's G plus 60. Okay, so let's form an equation. Boys plus girls equals to 280. So boys with G plus 60 plus G equals to 280. You add them together, and then you get this, and then minus 60 on both sides, divide 2 on both sides, and you'll find out that the number of girls is 110. And we are not done yet with the question. We are asked how many points did the girls obtain, and we are told that each student would obtain 2 points if they complete the run in 1 hour. So that would mean that 110 girls were successful and they got 2 points each. So the number of points obtained will be 110 times 2, and that will be 220 points. Alright, next question. The total savings of Ella and Zahida was 2,000. Ella and Zahida each donated this 1 over 4 and 1 over 5 of their savings, okay, to an old folks home. So Ella would give 1 over 4 of her savings. Zahida would give 1 over 5 of their savings. Okay, but we don't know the savings of Ella nor Zahida, okay, which would amount to 2,000 lah. Okay, the total amount donated by them was 440. So this amount times her savings, and this one times her savings will become 440. What are the balances of Ella's and Zahida's savings now? Okay, so let's define our terms first. Let the savings of Ella and Zahida be E and Z respectively first. So this will be E and this will be Z. Okay, and we found out that Ella's savings plus Zahida's saving is 2,000, which is E plus Z equals to 2,000. And then 1 over 4 of Ella's saving, which is 1 over 4 of E, and 1 over 5 of Z adds together would become 440, which we'll get here. Okay, and then we'll switch it into an equation that is much easier to solve later. So E over 4 plus Z over 5 equals to 440. Okay, now so let's see, we have equation 1 and equation 2 now here, and we can do simultaneous equations now. Okay, in this case I would prefer using substitution. Okay, I would prefer using substitution because I have one variable here, okay, with coefficient 1, which later I can which I can represent which I can represent E or Z anyhow you like as my subject first. And once I have this, I can I can just easily just sub E, okay, which I have here, into equation 2. Okay, so let's see. Substitute 3. Okay, wait. Okay, so substitute 3, which is E. Since E equals to this, the E here in equation 2 would also be equal to this. Substitute 3 into 2, substitute 3 E into this E, which is in equation 2. So you get 2000 minus Z over 4 plus this equals to 440. Okay, now the thing is, I would like to get rid of the fractions here because it's pretty messy to make the denominator same and everything. So as we have mentioned before, according to the equality concept, okay, whatever you do on the left hand side, you must also do on the right hand side. Okay, so if the left hand side, okay, how would I get rid of the fraction 4? I'll get rid of the fraction 4 by multiplying both sides by 4. So here times 4, here times 4. So let's see, if I multiply here by 4, then you see I can cut this off and I can simplify this, and then yep, I'll get this. But don't forget, here I multiply by 4, and every term needs to be multiplied by 4 on both sides. So that is where I get multiplied by 4, 4z over 5, and 440 times 4. And then I would like to get rid of this, so I'll multiply each term by 5, here times 5, here times 5, okay, and so I'll get yep, and your z as well times 5. So 10,000 minus 5z plus got rid of the over 5, 4z equals to 8800. Okay, so and then I'll start gathering the like terms. Negative 5z plus 4z equals to negative z. 10,000 minus z equals to 8,800. Minus 10,000 on both sides. And then I'll get this, and then I'll get the z equals to 1,200. Okay, and I'm not done yet. Okay, I've only found z, which is Zahida's Zahida's savings. Okay, give me a second. Let me see if there's any shortcut. Hold on now. Okay, yeah, no problem. Okay, sorry. Yeah, alright. Okay, so back here. Okay, now that I've found z, I'll label this as equation 4, and I'll substitute. Okay, and now after I found z, I would like to find what e is. Okay, and so what should I substitute in? Okay, take a look at here. I've got equation 1, 2, and 3, and because I want e as my subject, just take a look here. I have e as my subject here in equation 3. So why not I substitute 4 into 3. Okay, so substitute 4 into 3. So 4, which is z, equals to 1,200, which is also equals to the z over here. So e equals to 2,000 minus 1,200, and I'll get that e equals to this. So this is Ella's savings, and this is Zahida's savings. We are also still not done yet with the question, okay, because we are told to find the balance of Ella's and Zahida's savings. Okay, the balance means y 剩下多少. So the balance of Ella's savings 就是等于他之前有了的 savings, okay, 他之前有的 savings 再减掉他的 donation. So 他的 initial savings 是800, okay, 然后他减掉他已经 donate 掉的钱。他 donate 掉的钱呢，也就是他 donate 掉的钱，也就是800乘他刚才捐的1/4。So it'll be 800 minus 200, it'll be 600. Zahida 也是一样。1,200 minus 1,200 times 1 over 5 equals to 1,200 minus 240 equals to 960. Next, okay, alright, so done. Next question. An online dealer sells two types of clothes, baju kurung and baju kebaya. The profit obtained by from a baju kurung is 10 ringgit less than the profit obtained by a baju kebaya. He earns a profit of 275 ringgit from the sales of 5 baju kurung and 8 baju kebaya during the first week. In the second week, he sells 9 baju kurung and 7 baju kebaya. What is his profit in the second week? Okay, so and on let's see. It seems more like it to be a simultaneous equations, okay, for this question, because you have this 5 times baju kurung, the profit, and 8 during the first week, and then you get this profit. Wait. No, it's not a simultaneous equation. Sorry, okay, my mistake. Because I have 9 and 7 and I don't have a value here. Okay, let's see. What other information do we have? Okay, the baju kurung is 10 less than the profit from baju kebaya. So let's say if the baju kebaya is K, so the profit for baju kurung is 10 less, so it's K minus 10. Okay, so he earns a profit of 275 from 5 kurung and 5 kebaya. So can we form an equation here? We can. So 5 of baju kurung, which is 10 minus K, plus 8 of the profit of the baju kebaya, which is K, equals to 275. Yep, this is in a linear equation with one variable. So the distributive law, then we get this. Okay, we try to gather the like terms together, so we plus 50 on both sides. Okay, 13K, 3 to 5, shift it over, then you get K equals to 25. Okay, we are not done with the question yet. Okay, we are told to find the profit in the second week. So the profit in the second week would be 9 baju kurung, which is 10 minus K, and 7 baju kebaya, which is K. So K, we have already found what K is, which is 25 minus 10. Okay, and then you solve all the way down, you get that the profit in the second week will be 310 ringgit. Alright, okay, next question. The perimeter of the rectangle is 56, length reduced by 2, width increased by 4, a square is formed. What is the area of the rectangle? Okay, so the perimeter of a square, of a rectangle is 56. So let the length and width of the rectangle be L and W respectively. This is your rectangle, and the perimeter will be equal to all of these added together. So 2L plus 2W equals to 56. Now, next, the information given is the length is reduced by 2 cm and the width is increased by 4 cm. A square is formed. Okay, so that would be L minus 2, and this will be W plus 4. And since a square is formed, that means all sides will be equal, right? So a square has all equal sides, okay? And if it's the same, so that means L minus 2 equal to W plus 4. So 这边是同样的，因为是正方形。Okay, so L equals to W plus 4 minus 2. Okay, wait, what is going on here? Okay, please ignore this line. I think I've written this line wrongly. Okay, so ignore this line. So I plus 2 on both sides, so I'll get rid of this. So I'll jump here. L equals to W plus 4 plus 2, and L equals to W plus 6. Okay, and then I have this one, equation 3, and I've obtained equation 3 from equation 2. So I think I can do substitution here by substituting 3 into 1, so that I can find W, right? Okay, remember I'm not done. I've okay. So substitute 3 into 1, substitute 3 into 1. So L will be W plus 6. So 2L, which is equals to W plus 6, plus 2W equals to this. Expand it off, and then go all the way here. You'll find that W equals to 11. Okay, I'm not done. I still have to find W. So substitute 4 into 3, because I want to find because I would like to find L as my subject later. Okay, so because I want to find L as my subject later, so I already have equation 3. As long as I can sub something here, then I'll get L. So L equals to W plus 6, W which is 11 plus 6 equals to 70. So there, I got it. This is my answer. Okay, the area of the rectangle equals to the length times width equals to 17 times 11 equals to 187. Alright, okay, next question. The incomplete receipt shows the expenses of Lisa and Kayling at Sedap restaurant. The price of a cup of coffee is 1 ringgit more than the price of a piece of curry puff. What are the prices of a cup of coffee and a piece of curry puff? Alright, okay, so let's see. The information given here is the price of a cup of coffee is 1 ringgit more than the price of a piece of curry puff. So can we first let us define our terms and then see we can form a linear equation here. The price of a cup of coffee is, so when you have is, put an equal, is 1 ringgit more plus 1 of a piece of curry puff. So it's actually C equals to the price of curry puff P, and it's more 1, so it's plus 1. Next, we can form another linear equation out of the receipt here. So she bought 2 cups of coffee and 4 curry puffs, and she gave a total of 6 ringgit and 80 cents. So 2 coffee, 2C, plus 4 curry puffs, 2P, 2C plus 4P equals to 6.8. Okay, so since we already have okay, now should we use substitution elimination here? Okay, so let's take a look. We already have an equation where the variable is coefficient 1, and not only that, we already have the variable expressed as the subject, so we can directly substitute C into this C. So we substitute equation 1 into 2. So 2C, which is P plus 1, equals to this. Go all the way down, you get P equals to 0.8. Substitute 3 into 1 because we have only found P, we haven't found C. Okay, and we already have C as the subject here, right? So if only we could substitute P, okay, 0.8 into this, then we will be able to find C. C equals to 0.8 plus 1, 1.8. So the prices of a cup of coffee and the piece of curry puff will be 180 and 80 cents. Alright. Okay, next question. Encik Razal and his wife brought their children below 12 years old along with them for a holiday in Pulau Redang. They spent a total amount of 1150 ringgit for the package tour. The fees of an adult and a child is 350 and 150 ringgit. How many children did he bring with him? Okay, at first glance, when I was doing this, I couldn't tell whether it was a linear equation with one variable or a simultaneous equation. So I just write out the equations that I know. I just write out the information that I have, and then we'll along as you solve the question, you'll be able to figure it out. Okay, so let the number of children be x. Okay, since we don't know the number of children that he brought along with him, so Encik Razal and his wife, which is two adults, okay, plus x will be equals to the number of people who were there, y. Okay, I don't know if this equation will be useful later, but anyway, I just put it there first. Okay, and they spent a total amount of 1150. Why did they pay 1150? Because they paid for the fees for an adult, and the fees for adult, which is 350, and the fees for children, which is 150, but we don't know how many children were they. But we know that there were 2 adults. So the equation: two adults went, and each ticket is 350, plus x children went there. He brought x children, okay, and for each children it's 150 ringgit. So they paid 1150 altogether. And wait, let me see. This is a equation with one variable. I think I can solve x immediately. Okay, so let's see. 700, 150x, and you can go all the way down. You'll find that x equals to 3. I've already found the number of children, so he brought 3 children with him. Okay, so I've got this answer. So, well, I guess that this equation wouldn't be useful in the first place. Alright, so, okay, done. Next question. Okay, Asnita, okay, so let's take a look here. Asnita says that my age is X years more than your age. Your age refers to Raslina because she's talking to Raslina. Okay, so let's say if Anita's age be A and Raslina be R. Okay, so my age, my age, which is A, is X years more than your age, which is R. Okay, and Reslina age says that I was 13 years old X ago. That means Reslina age is now R, but 13 years ago she was X. She was 13 years ago she was uh X years old. So 13 years. When she was 13 years old, it is actually R, her age now, minus X years ago. Do you agree? Okay, let me repeat. Reslina, okay, I was 13 years old. I was 13 years old. Why is she 13 years old? That refers to her age X years ago, which is minus X. Okay, so Asnita also says that I will be 31 years old. How is she 31 years old? It is when her age this year, X years later, which is plus X. Okay, so there we go. We have 3 equations here. And wow, the strange thing here is we have 3 variables now. We have A, we have R, we have X. What are we going to do? Okay, so when we have 3 variables, let's just shift it into change it into 2 variables. Okay, how do we change it into 2 variables? Is there a possibility we can substitute something to something? Okay, let's see. I've been given A as a subject here, and there's another A here. Can I substitute A inside so that I'm left with this equation and this equation? Okay, let's see. Substitute 1 into 3. There you go. I've got this. Okay, 31 equals to A, which is R plus X, and I got this. Now, so let's see. I've derived this equation, okay, from this equation from equation 3 and equation 1. Okay, equation 2 is untouched yet. Okay, so let's see. I have these 2 equations, R and X, and I have this equation at R and X. I guess these 2 would be my simultaneous linear equations, wouldn't it be? Alright, so from 这两个 equation, okay, let's see, maybe I could do elimination. Okay, 因为我有两个 variable variable with the same coefficient. I think I did elimination here. Yes, I did. Okay, so let's see. Should we plus both equations, add both equations together, or minus? If I got positive R and I got positive R, I think I would minus, because R minus R equals to 0, and I would be able to eliminate or let my R disappear. Okay, so for equation 4 minus equation 2, so 31 minus 13 equals to R plus 2X minus the whole thing here. Remember to put your brackets, R minus X. So 31 minus 13 equals to 18. Okay, and then you'll get all the way down here and you'll find that X equals to 6. Okay, now we are not done yet. We are told to find the ages of Asnita and Reslina. So what are the ages? The age the age is represented by A and R. So we need to find A and R. Okay. So what should we do? Do we have okay, maybe okay, I was thinking that I thought I could substitute X equation 5 into equation 1, so that because I want A as my subject, right? But I'll find that later A equals to R, which I don't know yet, plus 6. So in the end, I'm going nowhere. So let's see. If I want to find A, okay, I just need to substitute X here, and then I can shift it over or minus X by both sides, and then I can find A later. So it is with what R. Okay, so let's see. Okay, now substitute 5 into 2. Substitute 5, which is X equals to 6, into 2. Equation 2 says 13 equals to R minus X. X equals to 6, and I'll find that, oh, R equals to 19. Okay, substitute 5 into equation 3, as I've said just now. Now I get this, and I substitute X, and then yeah, 31 equals to A plus X, which is 6, and then I found that A equals to 25. Okay, so I found both of their ages already. Okay, done. Next question. The straight line graph represents the population of trees planted in the districts of P and Q since the year 2010. The linear equations represented by the straight lines graphs of district P and Q are this and this equation. N, okay, take note, N is the n is the population of trees, and x is the number of years after 2010. In which year would the population of trees planted in both the districts be the same? Okay, say the population of the trees in that year. Okay, we don't need to define anything since they've already given you and they've told you what n is and x is. Or we say let this and this be n and x respectively. Okay, so let's form. Okay, we don't even need to form the equation. They've already given you the equation. Now, but what they want you to find is which year the population would be the same. Okay, this is the population. Okay, and we want to find out which year here, which year, okay, over here, which year, okay, will the population of the trees be the same in both districts. So in district QR, the population of trees increase. In district P, the population of trees also increase throughout the years. Okay, the time where the population of the trees are the same is at the intersection point, wouldn't it be? At this point, district P and district Q has the same population of trees, and it will be on this year. Okay, so let's see. So what I think with this graph, the question is trying to tell us that with simultaneous equations of these two equations, we'll be able to find x, which is the year which the population of the trees will be the same, 对吗? Okay, so 当我们能找到它的solution for 这两个 equation 它给你的，我们就能找到 x， 也就是找到 x， 我们就能找到哪一个年份它的 population of trees 是一样的。 OK， 明白吗？我看还需要再解释吗？呀，应该是明白了啩。 OK， 因为我要找哪一年 District P 和 District Q 我有同一个 amount of trees， 同一个 amount of trees。 So 这边 which is the intersection point， OK， 就是我能找到这个 x 了。 OK， 我要怎么找 intersection point？ I solve these two simultaneously 了。 OK， time 因为没有给你 value， so I cannot solve it graphically. Alright, too bad. So 我一定要 solve either with simultaneous with substitution or elimination. Okay, I've both n as my variable with the same coefficient. I think I'll do elimination. Okay, equation 1 minus equation 2. So equation 1 minus the whole thing, equation 2, and then expand it off. Remember, distributive law, and then go all the way down and get x equals to 3. Okay, so I found the solution for x. Okay, I would also like to find the solution for n. I would like to find a solution that could solve both equations simultaneously. So I don't have anything expressed as n as my subject. Okay, I don't have like n equals to something, but it's okay. I can either sub into 1 or 2. So I think 1 is simpler. So substitute 3, which is x equals to 3 into equation 1. So 1 says that n minus 3x, which is equals to 3 equals to 16. Solve it and you'll find that x equals to 25. Okay, then explain your answers. Okay, x is the number of years after 2010. So the year which the population is the same, okay, is 2010 plus x. 因为 x is 2010年之后的多少年. Okay, so 2010 plus x. So the answer is 2013. And the population of 3 will be 25. Okay, because the population of 3 is n, so it's 25. Okay, alright. So there you go. Next question. Okay, Jacob Latif recorded the time for a 100-meter sprint by 3 students, Amir, Ben, and Ravi. The recorded time of Ben and Ravi is the same. The average time for 3 students is 13.3 seconds. However, they realized that the Amir's time was wrongly recorded. Okay, as 15.3 instead of 13.5. Okay, so this is what is recorded. Okay, and this is the actual. Okay, so calculate the actual average time of the 3. Okay, so the so-called let's define our terms and then let's form equations out of it. Okay, now so be very careful of this. Okay, because when you solve linear equations, that involves a time, you better explain what your A or your B means. Is it the time recorded or the actual time? Okay, so in this case, let the time recorded for Amir, okay, be A, and then let the time recorded for Ben and Ravi, okay, usually 我会写 let the recorded time for Amir and Ben and Ravi be A and B respectively, but 因为这边有三个 so I just split it off 啦，会比较容易看。Okay, 不然 A and B 我不知道那个 B 是 referring to Ben or Ravi or Amir or Ben and Amir. Okay, so okay, now let the time recorded for Amir be A, let the time recorded for Ben and Ravi be B. So how did they find the recorded average? 刚才他们怎么算？他们把三个加起来再除3，就等于这是我的 recorded 的average time 对吧？ Okay, so this is one equation that I formed, and this is another. Okay, so and then I'll get this. Now, but strangely, they told me that the actual time, okay, the A2, okay, which is the actual time, okay, the actual time for Amil is sorry. It is given that the recorded time for Amil is 15.3. But it is supposed to be 13.5. The recorded time is given already. Wait, so if the recorded time is given, can I straight away substitute it in? Yes, I can. Okay, so I substitute A back into this. Then it becomes a linear equation with one variable left. So 15.3, this, and then I'll get this. Okay, go all the way down. And then the actual time for Amir will be 13.5. Okay, which 他刚才有讲. So if I already know the actual time for Amil and also the actual and the recorded time for Ben and Ravi, actual and recorded time for Ben and Ravi 因为是一样的，没有改. So the actual average time will be the actual time for Amil plus the time for Ben and Ravi, which is B 刚才我们知道的, and you just average them out. Okay, so I'm done with this question. Next, a wholesaler supplies 2 kinds of fruits, pineapples and watermelons to stall A and B. Okay, total payments received by wholesaler from stall A. Okay, the wholesaler received 90 ringgit from stall A and 140 from stall B. Determine the price per kilogram of each kind of fruit. Okay, so let's define our terms. Okay, what we want to find is the price per kilogram. So we don't know the price per kilogram. Let the price per kilogram for the pineapple and watermelon be P and W respectively. Okay, so let's form linear equations out of this. We have been given the table. Why did the wholesaler receive 90 ringgit from stall A? Why did he receive 90 ringgit? Because the wholesaler gave stall A 15 kg of pineapples, right? So 15 kg of pineapples. How much does 1 kg of pineapple cost? P, which we don't know yet. So 15 so that means it will be 15 times P, which is 15 kg times the price of 1 kilogram plus 40 kilograms of watermelon, W, which is 40 times the price per kg, price per 1 kilogram, okay, equals to 90. Same here, 25p plus 60w equals to 140. Okay, so I think I could do elimination here because I don't have any variables with the same coefficient. 我没有一个 variable 前面是同一个号码的, so I have to create another 2 more equations where I have variables with the same coefficient. So equation 1, I times it by 6, so I get 240. This one also I times 4, so I get 240. Okay, so I multiply by all terms and both sides by 6 and by 4, and I get this. Next, okay, since I've got positive 240 and I've got positive 240, so I just minus it off. Minus this equation, then I can eliminate off this variable. So then I will get a linear equation with one variable. Okay, so equation 4 minus the whole thing of equation 3. I'll get this. Go all the way down. You solve P, solve of P, and you find that the solution for P, for subject P, would be 2. Okay, and now I would like to find what W is. I don't have any equation where like W equals to something, but it's okay. I can solve it into 1, 2, 3, 4. any of them, and I find that maybe equation 1 will be the most convenient. Okay, 最简单的啦. Okay, so substitute 5, that means substitute 5 which is p equals to 2 into equation 1. So 1 is 15p, which is equal to 2, plus 40w equals to this. Go all the way down, you'll find that you'll find that w equals to 1.5. Okay, so there we go. 我们找到 p, 我们找到 w. Yes, that is the price per kilogram we are trying to find. So the price per kilogram for pineapple and the watermelon is 2 and 150 respectively. Last question. All right. A company produces two types of pen drives, P and Q, in the year 2015. The profit earned from both the pen drives was this. Okay, so the profit I got from P 跟我的 profit 我拿到 from Q. Okay, add together it will be 350000. Can I define my terms first? Yeah. Okay. So okay, 不用紧. I'll explain later. In the year 2016, the profit earned from type P pen drive increased by 25%, and the profit earned from type Q decreased by 10%. Okay, so this profit increase and decrease add together for 2016 is 395500. So find the profit earned from each type of pen drive in the year 2016. Now, be very careful. They want 2016, not 2015. Okay, so first let us define our terms. Let the profit earned from the pen drive P and Q, because I know I want profit to be P and Q, okay, respectively. But our problem is we have 2 years. We got 2015 and 2016. So state which year it is, okay, that you are trying to mention. Okay, so P plus Q equals to 350000. Okay, because we know that the profit earned in 2015, okay, from pen drive P, which is small letter P, and Q, small letter Q, both add together is 350000. Okay, in the year 2016, P, let's see, okay, this is interesting, P at 25% and Q minus 10%. Okay, so now it's pretty confusing if I were to write like P this, okay, and plus like P Q minus 10%. This is very, very confusing. I mean, how are you going to solve it later? So is there a way that I can represent this second linear equation in where I have P and I have just coefficients in fractions or decimals or whatever? Okay, so let's take a look. P plus 25%, or P plus 25% of P is actually P plus 25 over 100 of P, right? So it's P plus 1 over P. Okay, so it's actually 4 over 4P. Okay, 1P is actually 4 over 4P plus 1 over 4P, which is equals to 5 over 4P. Okay, Q minus 10% of Q equals to 2 minus 10 over 100Q minus 2 equals to Q minus 1 over 10Q. There you go. 9 over 10Q. Okay, so P plus 25%, which is 1 over 4P, plus Q minus 10% of Q equals to 395500. Okay, and then just add them out together, 5 over 4P, 9 over 10Q. This is my second equation. Okay, let me see. Can I do substitution or elimination here? I think elimination will be much simpler, because no, substitution will be much simpler, because I have already a variable with coefficient 1. Okay, so if only I would shift Q to the other side, then I have P, and then there because I got equation 3 from 1, equation 2 is still not touched, so I can substitute equation 3, this P into P of equation 2. Substitute 3 into Q, 3 into 2, so 5 over 4 of P, which is this, okay, which is this, okay, plus 9 over 10Q equals to this. Okay, expand it off. Alright, no problem here. Okay, now 就好像刚才一样, I'm trying to get rid of all the fractions. Okay, so okay, you can minus off this part first. Okay, now you can use your primary school method. I've used the primary school method. I multiply both sides so that I can have the same denominator. Or with here, you can also do the same trick. Okay, I multiply 4 on every term on both sides first, and then later only I multiply 10, okay, on both sides of every term, so that I can get rid of the 4 first, and then I can get rid of the over 10, so that I can get a straight equation with no fractions, which is easier to solve. Okay, but here I chose to use the primary school method lah. Okay, so times 10 on both sides, it is still the same. Times 4 on both sides, it will still be the same. So there we have the same denominator. We can do addition already. Okay, here I've done perform my subtraction. Okay, so negative 50 over 40 plus 36 over 40, I'll get this. Okay, 我把它约减起来 get this. Okay, negative, I multiply negative 1 by both sides, then I get positive on both sides already. Okay, this one shift over, divide by this, times this one. Okay, shift it, and I'll get Q equals to 120,000. Okay, I've only found Q, I still want to find P. So 因为 okay, 所以每次我做 substitution 我就有这个advantage. I have Q and I'm trying to find an equation where P equals to where P is the subject. Do I have an equation like this? Yes, I do. P equals to 350,000 minus Q. So substitute 4, which is Q equals to 120,000 into equation 3, which is over here. Okay, so P equals to 350,000 minus Q, which is equals to this. There you go, I found P. I am still not done with my answer, because bear in mind, this P and Q is for 2015. They want to find the profit earned from each type in 2016. So what should I do? Okay, in 2016, the profit for P, okay, is P plus 25. It increased 25%, right? Which 我们刚才找的是这个 right? So the profit P is actually 5 over 4P. Okay, sub P inside, sub your P inside, and then you get this. It's the same as profit of Q, 9 over 10Q. Sub your Q inside, and there you go. Alright. So congratulations, okay, we are all done with the 12 questions of Lex practice. Okay, so thank you very much. Enjoy doing your homework. Thank you.